Hello, my name is Aditya Gaikwad. My subject is Operation Research and my topic is simulation. Introduction. A simulation is the limitation of the operation of real world process or system over time. Simulations require the use of models. The models represent the key characteristics or behaviors of the selected systems or process, whereas the simulation represents the evolution of the model over time. Often, computers are used to execute the simulation. Simulation is used in many contexts, such as a simulation of technology for performance, tuning or optimizing, safety engineering, testing, training, education, and video games. Simulation is also used with scientific modeling of natural systems or human systems to gain insight into their functioning, as in economics. Simulation can be used to show the eventual real effects of alternative conditions and courses of action. Simulation is also used when the real systems cannot be engaged because it may be not accessible or it may be dangerous or unacceptable or engaged, or it is being designed but not yet built, or it may simply not exist. Definition. A simulation is the imitation, duplication of the operation of real-world procedure systems. Over time, generation of artificial history and observation of the observation history. A model constructs a conceptual framework that describes a system. The behavior of a system that involves over time is studied by developing a simulation model. The model takes a set of express assumptions, mathematical, logical, symbolic relationship between the entities. The ultimate goal of modeling simulation of systems and plant performance. Abstract. Modern production process in chemical, pharmaceutical, and biological industries are characterized by complex process systems, which consist of different approaches and process steps. Modeling the entire process requires simulating all units altogether while taking into account interconnection between them. Nevertheless, in the area of solids processing, there is nowadays an unfilled gap from the side of computer support of process modeling in allowing effective optimization and prediction of the behavior of the whole plant. The paper presents a tool for flowsheet simulation, which allows the simulation of the stationary behavior of complex processes dealing with solids and its extension toward dynamic modeling. Also, a new simulation concept is proposed on the basis of the mathematical approach on the macroscale flowsheet simulation is performed with the help of the solid sim system. Parameters for the macro models in solid sim are predicted by macroscale simulation. The models for the two scales are then coupled by interscale communication laws. Application of the purpose modeling concept is shown by an example of fluid bed granulation. Graphical abstract. The simulation to entire process the solid processing on the basis of multi-scale approach. Flowsheet simulation is performed at macro scale with the help of the solid sim system, which allows simulations of stationary behavior of complex processes dealing with solids and its extension toward dynamic modeling. Parameters for the macro models are predicted by physically based macro scale simulation with the models at the two scales coupled by interscale communication laws. When simulation is an appropriate tool, it enables one to study internal interactions of a complex system or a subsystem within a complex system. The effects of information, organization, and environmental changes on the model's behavior can be simulated and observed. The performance of the systems under investigation can be improved by knowledge gained from simulations. Simulation results can be helped to find which variables are the most important ones and how variables interact. It can be used as a learning tool. It can be used to verify analytical solutions. By simulating the capabilities for McDonald's, we can be determined. Simulation model designing for training allow learning without any cost. Simulation in the form of animation can show the system in action so that the plan can be visualized. The interaction in modern complex systems like factory, water, fabrication, etc. can be treated only through simulation. When simulation is not appropriate tool, problem is solvable by common sense Problem can be solved mathematically. Direct experiments are easier. Simulation costs exceed the savings. Simulation require time which is not available. No data is available and simulation needed data. Simulation cannot be verified and validated. System behavior is too complex or unknown. Advantage and disadvantage of simulation. Advantage: it can avoid danger and loss of life. Condition can be varied and outcome investigated. Critical situation can be investigated without risk. It is a cost effective. Simulation can be sped up so behavior can be studied easily over a long period of time. Simulation can be slowed down to study behavior more closely. Disadvantage: it can be expensive to measure how one thing affects another, to take the initial measurements and to create the model itself, such as the aerodynamic wind tunnels. To simulate something, a thorough understanding is needed and a awareness of all the factors involved. Without this, simulation cannot be created. Areas of simulation. So, logistic simulation optimize complex and dynamic logistic processes with simulation. Simulation in production, production planning, emulation, planning of machine scheduling, station simulation, personal simulation, supply chain simulation. Steps and simulation. Problem definition, project planning, system definition, model formulation, input data collection and analysis, model verification and validation, experimental and analysis, documentation and implementation. Steps of decision for conducting a simulation study. Start, define problem, problems appropriate, stop, benefits, exchange cost, planning and scheduling, abstract resources. System can be defined, specify system parameters, form using model. Data can be collection of data collection and analysis, model translation. Modeling, verify and validated, experimental and analysis, documentation and evaluation. Thank you.